Okay, hey everyone. I'm Kay Williams. I am, and I'm with Santiago, and we are here to talk about software supply chain security. We're really talking about kind of a shift in focus in supply chain security, where we want to take it as an industry approach. So we want to work on some common standards and some common, even some common implementations to make the overall software supply chain more secure. So I work for Microsoft. I'm a principal program manager. I work in the Azure office of the CTO, and my job at Microsoft is to be thinking about, what the future of software supply chain security is. I also am the chair of the security SIG for the CDF, and then I'm a co-chair for a group that's working on standards around a software bill of materials, and I'll tell you more about that. And Santiago, who's with me, is a PhD student at New York University in the Center for Cybersecurity, and he works on a project called In Toto. And so we've been collaborating, but a bunch of other people are collaborating as well. Okay, great. Thank you. Okay, so we're going to cover a couple of concepts quickly, and then we'll talk about a few user scenarios. And then we've got a demo of In Toto and KubeSec, and Santiago will give that. Then we'll talk about the industry collaboration that's going on, the time frame that we're looking for, and then how you all can get, any of you who are interested can get involved. So when we talk about software supply chain as an overview, we're talking about everything all the way from the developer who writes code through to package managers and package management repositories to application developers and the applications that they provide, and all the way on to end customer systems, whether those systems be virtual machines or containers that run in the cloud or desktops or laptops. We're really thinking about the overall scope of the software supply chain. And our goal, or the job to be done, is that as a participant in the supply chain, I can both produce and consume trustworthy software. So now we have a couple of the concept parts. I'll try to go through this quickly because it could get a little boring. But in general, we think of the software supply chain as having producers and consumers at each point, at each link in the supply chain. And the producers produce artifacts, and they store information about those artifacts and make that information available through artifact repositories or metadata repositories. Information that's in metadata repositories gets transferred to consumers using something that we call a software bill of materials. And then the consumers write policy to say what they require from an artifact. And then they inspect the artifacts they get against the bill of materials that they consume to verify that what they're receiving meets their policies. So what's an artifact? A component of software, anything from a file to a package repository. It could be a container, a cloud service. It could even be a full installed system, or it could be as small as a snippet for some scenarios where it's a byte range in a file. Artifact metadata describes the artifacts. So that includes things like the identities of the artifact, the name, the producer, the version, and a hash of the artifact. The information that identifies the authenticity of the heart of the artifact, so a cryptographic signature. Build information, so how was this artifact produced? What tools were used? What was the build environment? What's the configuration? Intellectual property information can go in, is metadata about an artifact. And then also relationships with other artifacts. So this artifact describes a different artifact, or it contains an additional artifact. Metadata repositories are responsible for distributing metadata. So they deal with storage, query, and retrieval of artifact metadata. The repositories also deal with cryptographically signing metadata and then managing key distribution, revocation, and replacement. And so in the future, we see there being many, many metadata repositories. In fact, we think these will be associated with many of the systems we use today, whether those systems be source code repositories, container registries, package repositories, or even installed systems. The software bill of materials is an exchange format, a data format that allows for exchange between the producers and consumers. We're looking at doing that in a standard format based on XML, which is called XMI for XML metadata interchange. But this same format can be converted to other formats like JSON and XML. Artifact policy describes the requirements, on the consumption side, the requirements for consuming artifacts. So it might say things like who are the allowed producers, the allowed licenses, what build requirements, or what do I require from a build environment that I'm willing to consume from? What are some security steps that are required before I'm willing to consume? Maybe some industry certifications. And then also something in the policy is an expected order of steps in the chain. And so this will do things like prevent man in the middle of attacks, so someone can't get into the chain that you weren't expecting to get in there. And also help specify things like, in order for me to release, I have to have a security audit met and maybe some industry compliance standard met. And then at that point, I will agree to consume and release this product, this artifact. And then the last piece is the artifact verification. And so this allows inspection and policy enforcement of artifacts. And this is where there may be some opportunity for industry collaboration on creating some common types of inspections of artifacts. So that's all those are all the concepts and some definitions. Let's talk about user scenarios now. The types of scenarios that we are expecting to deal with in our software supply chain framework, we group those into 6 categories. One is identity, so we want to be able to provide an unambiguous identity for any artifact. And that identity includes the name, the producer, the version, and the hash of the artifact. And this allows the sort of reliable consumption, purchase, transfer, inventory of artifacts, and even association of artifacts with outside databases, for example, CVE databases. Another area that we're concerned with is build security, which is being able to validate the choices made during the build of an artifact were secure or followed a process that we expected to follow. Authenticity, so ability to validate the software provider. Integrity, so making sure that the product or the artifact I receive wasn't tampered with in the process of coming to me. License, and then chain of custody. And I talked a little about chain of custody previously. So if we dive into a couple of scenarios just to make the use cases slightly more concrete. So one is and this is a scenario around identity, and this deals with security vulnerability. So in this case, there's a developer. In step 1, a developer would make a commit into a source code repository. And the source code repository would provide a metadata metadata repo, and make that commit available along with a bill of materials describing the commit. And let's call that bill of materials SBOM1. At any rate, inside of that bill of materials, there is a unique identity for that specific commit. That commit then gets rolled up into a package. Maybe it's an RPM or a Debian or something. And then that package further can be used inside of It can be installed onto an end user system. It could be installed into a container. It could be installed into a cloud service, or maybe it's installed into a container, which is then used in a cloud service. And then at some point later, a security professional identifies a new zero-day vulnerability, and that vulnerability is tied to that specific commit. And now, because we've got a unique identity back to that commit, and the identity flows through all of the systems and becomes part of the metadata repository at each one of those chain points, it becomes very easy for scanning tools to be able to query metadata repos to find out definitively if that vulnerability exists on an installed system, in a cloud service, in a container, et cetera. So that's one example. Another scenario is an integrity scenario, and this has to deal with enforcing a signature and hash. So in this case, a build system would build artifacts, and then inside of a metadata repository, there'd be information about the built artifacts. A release system could query the build system metadata, obtain the SBOM for that, and then use the software bill of materials and validate against a policy that the release system, or whoever is creating the policy on the consumption side. So on the consumption side, someone would create the policy. It might say, we only accept artifacts that come from a certain build system or have certain build properties on them. And let's see. Okay, so anyway, so there's policy on the consumption side, and then also on the consumption side, there would be some verification. Was this from an allowed build system? Do the hashes of the artifacts I receive match the hashes that were in the bill of materials? Okay, and the last one I'll talk about, which is going to lead us into a demo, is a chain of custody scenario. And so this one deals with enforcing certifications. So we'll build on the last scenario. In this case, we have a build system, and it builds artifacts, and it makes those artifacts available. Now we've inserted a new link in our chain, and this is a compliance service. So you might imagine this would be some sort of security scanning service. So that compliance service would receive the artifacts, the build artifacts, and also the bill of materials for those artifacts. And then it would go about scanning, or this might even be something that's manually done. Maybe there's an SDL life cycle certification that needs to be done. So this would be completed, and then an artifact of this might be a compliance report. And then this compliance service would also provide a repository, a metadata repository. And now in this case, the release system would consume from the compliance service, and it would use both the bill of materials for the built artifacts and from the compliance service to check against a policy. And in this case, the policy would say that the compliance service both needs to be in the chain before I received it, and then also the compliance report must be positive according to whatever criteria I specify. Okay, so let's take a look at this compliance scenario.
Let's check it out.
Yeah, check it out, and kind of in terms of in toto.
Okay. Oh, wow, okay. That is a problem. So let's go back to this. Let me fix my screen for a second. What was the?
You're looking for the screen resolution.
So I didn't notice that it ate half of the screen. Okay. Hold on a second.
Okay, while he's fixing that, I'll go ahead because I have a few more things that we were going to switch to after he finishes anyway. So We view this software supply chain work that we're doing as a big industry collaboration that crosses a bunch of existing tools. And so we think it requires some integrations with many tools that are out there today. And we think this is just a partial list that I'm putting up on the screen, but we think IDEs, frameworks, cloud, container repositories, source code and package repositories, existing software update systems like apt-get and Yum, and even Windows Update and proprietary software update systems, and also runtime security systems, because we want this same ability to apply and enforce policies to run on desktops and laptops. Okay.
Thank you.
You're welcome.
Okay, so I'm going to take all of this context that was super useful about the state of software supply chain security and all of the amazing things that we can do once we take in a little bit of tooling and a little bit of metadata and we float it around in the right way. So I'm going to start with this question, how is software shipped? Because, well, software supply chain and the Continuous Delivery Foundation is pretty much trying to answer how can we make a product reach to the end user in a trustworthy, reliable, stable fashion. So Kay had a lot of examples, different package repositories. I tried to pick a couple of logos here that people found familiar. And let's say that this is our cartoonish minimal working example. We have a version control system where we checked in our source code. Then we probably have a hook that is constantly building new commits and it's testing things out. We have a build farm or a build server that's taking that commit and building it, and probably we eventually push everything out into a package, in this case a Debian package, and that Debian package ends up in Artifactory or somewhere else. Now, we want to have all of this information captured as a whole. In toto is in fact Latin for as a whole. And we're going to do this by using two pieces of information. Two types of pieces of information, to be quite precise. The first one is something that we call a layout, which is a map. Many people here are probably familiar with Jenkins, in which you have something like a Jenkins file that tells you, well, these are all of the steps that I am going to perform. And, but in toto also adds other information, like what we call the functionaries. What are the actors that are allowed to perform operations in this pipeline? In this case, we have 4 people, Dave, Aaron, you can read the names. I can't. I have to fiddle with the screen. But they are there, and they are only the only person and the only people that are allowed to partake in these activities. So we are also going to give them a list of products and artifacts that they can create and they can transfer around. In this case, for example, the version control system can only produce source files, and the CI or CD system can only create binaries and can only report the status of a build. And finally, a packaging step is the only one that can produce a package. Then we link everything together. We have in the layout, we also say the sources that were created by the version control system are the ones that are going to be input into the build farm, and the binaries that were created by the build farm are going to be input into the packaging step. And then we have an authoritative entity that declares all of this. In this case, Alice signs this layout using her private key. So we have a cryptographic signature, and we know that Alice is the one that is the project owner, a product manager, a BDFL in an open source project that will say, this is what needs to happen, and here's my rubber stamp to tell you how things should be followed to the letter. Now that we know what needs to happen, the next question is, can we gather evidence, or can we check that what needs to happen actually happened? So we have this other type of information called link metadata. And we use the term link because the supply chain is a series of conjoined links. These are mostly rubber stamps over the operations that each of these functionaries or individuals in the supply chain performed. They will say, this is what I did. These are the things that I took as materials in, for example, source code. And this is what I produced, for example, a binary. Now, finally, when you're about to consume a piece of software, you can take this policy as Kay referred to, and we can take this series of attestations or pieces of linked metadata, and then we can essentially start walking back the paper trail and make sure that everything was followed to the letter. Now, I'm going to go to a demo using a tool. I'm going to make not even this big supply chain, but I'm going to make something a little bit smaller. But I'm going to try to live code it here. And even though we, we already had a blunder with the projector, I am pretty confident that we'll try to get something done. So the first thing that I'm going to ask is, does this look like a terminal?
Okay.
Great. Does this look like a terminal you can read? No? Yes? A little bigger? What is there? Okay, this is not what we're looking for, though. Wrong terminal. This looks like sad bytes. Oh, there we go. This is it. So here I have a solved supply chain in which we're connecting. Somebody created a Kubernetes deployment and is going to send it to a third-party service called kubesec. Is anyone here familiar with kubesec? So yes, some hands, but just so everybody's on the know, kubesec is a service that scans your Kubernetes deployments and returns a series of reports. So going back to our presentation, we have two steps, two people that can partake in these activities. One of them is the person who created the deployment. The other one is kubesec, the company that will create the signed attestation saying, I received your deployment, I'm going to scan it, and I'm going to return a software bill of materials saying, this is the result of my scan. So back to kubesec. Let me see if I can get away with attaching to this, so I don't have to look into this. Okay, yeah. Can you guys see my cursor? So I'm going to zoom in here. I wrote this little script using in Toto, the Python implementation. And there's basically three things going on here. I'm sorry over there if the angle is too wide. But I imported a couple of helper tools. Then I created a new layout. Then I loaded the keys of the functionaries that will partake in this layout. We have the project owner, which was Alice. We have Bob, which will create the deployment YAML. And then we'll have the key, the public key of kubesec. We don't need the private key. kubesec will sign it whenever we give our deployment to them. Then we create two steps in which we add restrictions. We have a very minimal domain-specific language that helps us link things together. First, we have the step of creating the deployment. So you wouldn't be surprised if there's a rule that says, well, this person is allowed to create a deployment. And the person that's able to perform this is Bob. And then we have the scan phase in which we are giving the deployment to kubesec. In this case, we have a little bit of a more verbose rule. We say we require that the deployment YAML is part of the materials that were taken in by kubesec. And then the deployment YAML needs to match exactly to the letter, the one that was created by the original step. That is, there was no tampering in the fly, there was no lying between both parties, there was an actual handoff of our deployment file from the person who wrote the deployment into the scanner. And then we finally sign the whole thing, and we dump it into a file. So, okay, yeah, we're here. So I created the attestations, but we can recreate them. We can you can run in Toto the tool, and you can essentially test it, tell it to create a rubber stamp file that says, I'm going to create a deployment, so create a signed rubber stamp with my key, reporting this as a product. So we do this. So we pretty much do this. Oh, I'm in the wrong directory. This is how you know it's live. There's a So I created a rubber-stamped piece of link metadata. It has the things that you expect to have inside of it. It has information about the environment that was captured. There's a cryptographic signature over the whole attestation, and then there's a hash over the deployment file. So we have an integrity check over the deployment. Then we can do exactly the same for kubesec. I'm going to talk to the server of the kubesec server. In this case, it's on localhost. I didn't trust the spotty Wi-Fi, but I will basically send up the deployment file to kubesec. It will reply to me with a JSON object, and inside of the JSON object, I have a rubber stamp that I'm going to extract and then serialize it into another piece of link metadata. So I do this, and now we're done. Now, finally, I'm going to verify both things. I'm going to make sure that both things match. So I'm going to run in toto verify. By the way, all of this is in Debian. You can run apt-get install in toto, or if you're using Arch Linux, you can do the same. You can start fiddling around. I'm going to talk a little bit more about how does this fit the whole cloud-native ecosystem and the whole continuous delivery ecosystem. But if I didn't screw anything up, this is going to give us a thumbs up. And it did. That's amazing. You can see I also enabled the verbose flag. You can see that it was checking that the layout wasn't expired. This means that you can have a policy that says, we created this policy in October, and the next review is going to be on January, so we need to either re-sign it or update our policy. It's also checking that, for example, you have attestations for all of the steps that were reported. You have a matching between all of the artifacts as they flowed through the chain, and that there's enough, pretty much that the policy was followed to the letter. Are we running out of time? Yes, okay. So to wrap up, how you can use Intoto today. You can either integrate Intoto into your product. Adding it to kubesec was using the Golang library, 50-line diff, you're done. You just pretty much need to integrate this. We have Python, Java implementations as well. Or you can use Intoto to secure your pipeline. I'm going to fast forward through this. I'm going to give a more in-depth demo of this tomorrow at 11. You can use the Jenkins plugin. In the Jenkins plugin, you can basically tell it to capture the same type of attestations as things are running automatically in your Jenkins-enabled pipeline. And then you can eventually verify everything as it gets into your admission controller if you're using Kubernetes, for example. And I'm going to fast forward through this. I think we're done.
You're done.
Sorry, I wasn't expecting to struggle this much.
Okay. All right, so just a couple of wrap-up things for you to know. So we are collaborating with a bunch of different companies as we work through the software supply chain design, and so these are some, and we're working to get more. And the goal is to do this really as a very open industry collaboration. Timeline, we got started in FY19. We've got a bill of materials working group going on, and we're working toward a standard with the object management group. So we'll have a draft standard out for that in FY20, and hopefully also for policy and artifact repositories. And we want to get a bunch of pilot implementations started in FY20, and then working towards standards, both through OMG and eventually through ISO standards in 2021 and 2022, and hopefully get a lot of production implementations by that time. Things can be done in production today using Intoto, but we want to get a lot of things built in natively to things like GitHub and Microsoft products and products by others. How can you get involved? So we are having a supply chain meetup that's going on Thursday from 9 until 12, and this is kind of more in depth of what we were talking about today, and anyone who wants to kind of be involved in helping to create the standards. That'll be in the conference room Torrey Pines 3 on the first floor. That's in the north tower of, I forgot to say, it's the Marriott Marquis. We do also have a Slack channel and a distribution list and a GitHub that are for SIG security supply chain. And then as Santiago mentioned, he's giving a couple of additional talks on Intoto, and then there's another project called Tough that's related, and those will be on Tuesday and Wednesday. Okay. Come find us later if you have questions. I think we're done. Thank you.
Thank you. I think there's a question over there.
How does this relate to the work that's done in Graphias and Curtis? Is there anything?
It's
Yeah.
absolutely in the crowd now. Well, yes.
Yeah. That Google and those projects are part of this industry collaboration, so we're working on that together. And the idea is we want them all to be, so Graphias and Critis will become projects that also support these supply chain security standards.
There's ongoing work for Graphias to be able to consume and host this type of in-total link metadata that you see. And Graphias can be used to very richly represent other cloud-native elements in depth. So you get integrity and a very quick, large schema of supply chain information.
Okay, cool. Thank you very much, Kay and Santiago. That was really cool.